All right, Dr. Aadeel Akhtar, welcome to Manufacturing Happy Hour. I'm not gonna lie, I had a lot of fun watching your Shark Tank episode right before we started doing this. So that was a new way to prepare for one of these episodes. You did a great job. We'll get into that later. I don't want to do any spoilers quite yet for anyone, but hey, in the spirit of Manufacturing Happy Hour, we describe things on this show in a candid fashion as if we're having a beverage with one another. So let's
All
say
right.
you and I, yeah, let's say you and I are hanging out in the hallway or at a happy hour at the Robotics Summit in Boston here in a little less than a month from when this comes out. How do you describe what psionic and the ability hand do if you're just meeting someone for the first time?
Yeah, so at Psionic, we develop advanced bionic limbs that are accessible for humans and robots, and I've got the ability hand with me right here. So you get to see a live demonstration of it as well too. So, for example, I'm using these two buttons to control it. If I was missing my hand, I could use my muscles and nerves directly. If I was a robot, then I can just use AI to control it as well. So we've made it for both humans and robots.
Do you always carry one of those ability hands around with you now? Because between this interview, the Shark Tank episode, I've only seen you with one of those in hand.
It might have become an extension of my body at this point. So yeah, I feel when I don't have it in hand, I'm aware of it not being in my hands.
Sure. Well, you've truly dedicated your life into developing this in some way, shape, or form, and that's what we'll dive into first before we get into a bit of the nuts and bolts of the ability hand and the work you're doing. If I recall correctly, you had an experience when you were 7 years old that ultimately set you on the path to creating this company. Tell us about that scenario.
Yeah, and so when I was seven, my parents are from Pakistan. I was born in the Chicago suburbs, but I was visiting Pakistan when I was seven, and that's the first time I met someone missing a limb. She was my age, missing her right leg, using a tree branch as a crutch, living in the streets. We were visiting like a bazaar for just shopping, and she was right around the corner. And that had a profound effect on me. We shared the same ethnic heritage, but we have such vastly different qualities of life, and that kind of spurred me to want to go and solve these kinds of issues in particular, with the original plan of becoming a medical doctor, and then it turned into something even bigger than that.
Well, that's an interesting point you bring up. At what point was it a moment? Was it an evolution that you realized that, hey, being a medical doctor is fine, but actually there's a different path I can take. What was that moment like? Tell us how that change started to happen.
Yeah, and so there were a couple moments in particular, and so the original plan was to become an MD that would work with people who have limb differences and amputations, right, so that we could get prosthetics on them. And it was my undergraduate, like when I was when I was at Loyola University Chicago for my undergraduate degree in biology. I took my first computer science class and I loved it. I loved everything about coding and building my own things. And I was like, if I become a straight up MD, I don't get to do any of this cool stuff. So how could I combine these like two interests in like prosthetics as well as engineering? And right down the street in Chicago, Illinois, in downtown Chicago, is a hospital called it used to be called the Rehabilitation Institute of Chicago. It's now known as the Shirley Ryan Ability Lab. It's the number one rehabilitation hospital in the U.S. for the last, I think, like 38 years or something like that. And they had these like, huge breakthroughs in these neurally powered bionic limbs, where they were like doing these surgeries where they would rewire nerves to different muscles in people's bodies, and then you could use those new nerve rewirings then to control this like multi-million dollar hand that was developed by like DARPA and Dean Kamen and Johns Hopkins. And when I saw this, I was like, this is it. This is exactly what I want to do. It's a perfect combination of engineering and clinical medicine and prosthetics. But one of the big problems was that those hands were just so expensive to do R&D on and manufacture, that from an accessibility standpoint, for someone in Pakistan, that wouldn't actually be something that they would ever be able to afford. And so I went down to get a master's in computer science from Loyola. I taught there for a couple of years, then went to the University of Illinois at Urbana-Champaign, entered their MD PhD program, got another master's in electrical and computer engineering, PhD in neuroscience, And then I had ended up leaving medical school. And part of the reason was because the original plan was that or I guess the modified plan was that I'd finish the MD PhD, work at an academic hospital, see patients like one day a week, and then do R&D on stuff like this for the rest of the week. And in the summer of 2014, we got the chance to go down to Quito, Ecuador. We were working with a nonprofit organization known as the Ranger Promotion Project. Their mission is to provide prosthetics to those who can't afford them in the U.S., Guatemala, and Ecuador. And I was in the middle of my PhD. We started like 3D printing our own hands at that time. And we had a very, very early prototype of the Ability hand. We internally call it Mark II. And it was 3 times the size of an average adult human hand with wires going everywhere, plugging into breadboards, power supplies in the wall. And our first patient ever, Juan Suquillo, he had lost his left hand 35 years prior due to a landmine explosion. He was in the Ecuadorian army. And he, in front of international news stations, said he felt as though a part of him had come back because he made a pinch with his left hand for the first time in 35 years. And that's when I realized if I stay in academia, if I have this plan of working at an academic hospital, this just ends up as a journal paper. And if we want everyone to feel the exact same way that Juan did, we had to commercialize this technology. And that's when PSYONIC was born.
Very cool. So, multiple moments that galvanized your experience on this path. Maybe this next question's less relevant now because I might have an idea of how you might answer it. But was there ever a point, because this took a long time to really, go through school, go through your PhD, get PSYONIC off the ground. Was there ever a point where you thought about just going a completely different direction? And if not, what would you say helped you stay on track and focus this whole time? Because a lot of stuff can happen over the course of a decade plus.
Yeah, this was always the goal. It was just a very circuitous route to get there, right? Like the original plan, MD, right? Then MD, PhD, then like PhD in engineering, then PhD in neuroscience, and then startup company, right? Like startup company was never part of the plan. And one of the reasons why like what really made that startup kind of path the most worth it was that I had to decide at one point whether I wanted to finish medical school while running PSYONIC or like we move the company to San Diego and we just go all in. And I had dinner with my M1 physiology professor, Dr. Kashif Ahmad, and he was telling me that, if you become an MD, then your impact will be very important, but it'll be very local to wherever you practice. What you can do with PSYONIC can have global impact. And I think that was the motivating factor behind it, was the most amount of impact that we can make. And really the best way to do that is through a startup that eventually grows into a large, mature company, right? Just affecting millions of people around the world with limb differences, but also like millions of companies who are using robots, and that will eventually be in manufacturing lines and in the home, etc. And I think that's what kind of kept everything like rooted and grounded, was like, how could we make the most beneficial impact on humanity, like depending on what path that we were going to go on. And fortunately, we're able to navigate that to where we're at now.
Yeah, and I'm sure the folks in manufacturing and robotics listen to this. They're going to take away a lot from your discernment process that you just shared throughout this story that allowed you to stick with your goals, because I know a lot of people listening to this have their own big visions and goals of their own. I want to pivot a little bit to talking about PSYONIC, and maybe my first question is, when I think of a robotics company or a robotics company with a medical spin, I default to cities like Boston, maybe rightly or wrongly, for example. What has made San Diego a sweet spot for this?
Yeah, so there's a big medtech and biotech hub in San Diego in particular, right? So we've got like companies like a bunch of orthopedic companies like NuVasive, Globus, and C-Spine. So there was like the whole orthopedic element there. And there's a bunch of accelerator programs, biotech coming out of University of California, San Diego. But a lot of the big reasons for us is that one is that we're working very closely with the Navy Hospital. So Dr. James Flint at the Navy Hospital and Dr. Kate Hinchcliffe at UCSD on the next generation of these bionic limbs. So for example, the way that these hands typically go on is you actually have something called like a socket, right? So this is a very fancy one that lights up according to like muscle sensors. But essentially, you'll put your arm inside the socket, and then we have two muscle sensors on the right and left sides. And then when those muscle sensors
Oh.
are activated, you can see actually these they're lighting up in particular, right? So when in response to the muscles, right? So it lights up much faster when you flex harder, and it lights up much slower, right? So you put your arm in here, and then the hand responds to that. And there's the muscle sensors are located on the outside of your body. And the thing is that that's kind of still like wearing a shoe over your arm. So it
Okay.
gets uncomfortable, it gets sweaty. You go under fluorescent lights, and the 60 hertz noise messes with like the electrical signals, right? And the way that a natural hand is connected to your body is through your bones, right? Your hand is
Mm.
connected to your bones. And so, what we're working with Dr. Flint on at the Navy Hospital is a titanium implant that can go directly into your bones and comes out of your body, and then the hand directly attaches to it. And instead of having the muscle sensors on the outside, with Dr. Hinchcliffe, she's implanting fine microwire electrodes directly into the nerves itself, into the muscles, and then those come through a port at the end of that titanium implant. And basically, you're connecting the hand directly to your bones and your muscles and your nerves, like a natural hand should be attached. And the idea
Wow.
there is that you, instead of doing like, I'm doing these pre-programmed grips, right? So this is like a power grip, like I can slide the thumb over, turn it into a thumbs up, like then we can do like a pinch, for example, right? But
Yeah.
it's not necessarily the most natural way of controlling. You're controlling these pre-programmed grips and then cycling through them, right? And with these nerve implants and these muscle implants through this bone connection, the idea is that you'd actually be able to do individual finger control. And so, Chris, we're going to do something fun here. You're actually going to get to control this hand that I'm holding, even though you're all the way. Are you in Boston?
I'm actually in Milwaukee, so a little
You're
kind
in
of
Milwaukee.
halfway between us. But let's see how this works as I
Yeah,
control it from Milwaukee.
exactly. So I'm in San Diego. You're in Milwaukee, and then if you just put your hand up to the camera, and we'll see
All right.
if I can actually get this recognized. Okay, yeah. So I got it right there, and then we'll go ahead and bend your fingers.
Yeah, look at that. Incredible. So for the folks listening to the audio version of this, I'm literally bending my fingers and the ability hand is responding in turn.
And you can do
Very
your
cool.
fingers too.
Oh yeah, let's do that. I'm gonna do a peace sign real
Let me
quick.
see if I
Let's
can get
see.
that back. I think we lost your hand when you had gotten it back on there.
Oh, got it. Okay.
Uh, okay, yeah. So let's try it now.
All right, we'll do it one more time here.
Yeah, there we go. Okay, and then
All right. And I'm going to do a peace sign here.
nice.
Excellent. And then one more thumbs up and we'll call it good. There we go. Excellent demo. One of the first times doing a demo like that on air.
And so yeah, so that's the next generation. That's the next generation of these devices, right? Where we can actually get this individual finger control working, right? And we're hoping that when we do clinical trials on this, that we'll have our first patients playing piano or typing on a keyboard again, and the future is going to be really exciting in that front.
Yeah, no, this is great. So really, if we were to summarize the way this works, if we were having a quick beverage, if you were chatting with someone at the bar, you're using a titanium implant and nerve and muscle implants, and that's what allows the hand to work. Let's say if it's attached to half of someone's arm, if you will. Is that correct? Or attached at their elbow? Or
Yep.
what would be a cleaner way just to clean that up
Yeah,
slightly?
like their forearm, exactly, right? So
Yeah.
we'd be attaching the hand directly to your bones, muscles, and nerves that are in
Mm-hmm.
your forearm, and to give them the most optimal control possible. And going back to your earlier question, so our goal in moving to San Diego was to bring together all these resources, like the military hospital, UCSD, and the Challenge Athletes Foundation. We've got the entertainment industry in LA, just like 2.5 hours north. We've got potential
Mm-hmm.
manufacturing in Tijuana, just like 40 minutes south, and just to bring all of those resources together and turn San Diego into the bionics capital of the world. And so we've got all those pieces together, and we're well on our way.
Very cool. Well, that makes a lot of sense. And I, from what I remembered about San Diego, I'm pretty sure there's a big orthopedic biotech
Yeah,
scene down there as well. So
exactly.
appreciate you taking us through that, as well as how the ability hand works. One thing that came up in our earlier conversations, I've got some business and, let's say manufacturability questions about this. You've mentioned the importance of, you met a girl in Pakistan, you met someone in Ecuador, right? You've traveled to a lot of different parts of the world, and you want to make this technology accessible to different people, not just something, let's say, a technology for those that can easily afford it, if you will. How are you prioritizing accessibility in your business?
Yeah, and so it's one of our core tenants. I mean, it's basically the lifeblood of the company, starting from the girl that I met in Pakistan, as well as when we worked with the Range of Motion project in Ecuador. And in the US, like when we started building these hands, it was a design goal from the beginning that we needed to get it covered under Medicare. Because if Medicare covered it, then usually all the other insurance companies will follow suit. And we were able to do that. And in doing that, we expanded access from 10% of patients who could afford the hand to 75% of Americans who can afford the most advanced bionic hand on the market. But that still leaves 25% who are uninsured, on Medicaid, or underinsured. And then 80% of amputees who are in developing nations, of whom less than 3% can afford an advanced bionic hand. And so we have this initiative called the Ability Fund that can partner with nonprofit organizations to raise funds to donate to get someone an ability hand. And most or recently, we've partnered with the Range of Motion Project, who this whole thing started from. And basically, for every 25K that's donated, it will completely cover all of the costs of a bionic hand and all the clinical services, as well as a leg. Bionic hand in the U.S., a leg in Guatemala or Ecuador, and this is typically like $100,000 to $150,000 worth of like devices and services that we're able to do at such a low price, so that we can get it to as many people as possible who need it. And that has been like an important mission for us, that we've been able to do this. And so our very first recipient of it, of the Ability Fund, is a local San Diego kid. He he was born without his hand, and he sent me an email while he was in high school and said that, is it okay if like I come visit you guys? I've loved robotics ever since I was little. And he came over to our offices, and for the first time in his life, he controlled a hand on his left side. And just this upcoming week, he's actually going to be fitted with his permanent hand that he's going to be going home with and using on a daily basis for the first time in his life. And this is why we do what we do.
No, that's incredible. And is that, maybe I'm connecting two things that aren't connected, but is this why crowdfunding has been part of your model as well, to involve that community aspect to make
Absolutely.
things like the Ability Fund possible?
And so one of the reasons why we went the crowdfunding route in particular was because if we're a company that's all about accessibility, why wouldn't we just make the company itself accessible? And one of the most beautiful things that came out of that is that our own users, our own wearers of the bionic hand, invested in the company. And that's something that you don't typically get a chance to do. And it's like we get to make this for them, and they get to be a part of it, making this for them. So I'm so glad that we were able to give that opportunity to many of our users.
A business question now. Has it been a challenge, or how have you navigated raising funds in a number of different areas? I mean, you get government grants. You've raised money through, I believe, Start Engine. You're doing crowdfunding. You have Shark Tank, which we'll get to a little later. I mean, that's a pretty unique, wide mix. How do you manage that, out of curiosity? And
Yeah, so a lot of the government grants, those stemmed from my background in doing a PhD, right? So
Mhm.
we worked with the National Science Foundation before, National Institute of Health, and so a lot of the R&D development that we do is kind of an extension of like a lot of the work that I was doing as part of my PhD. And so that was just a natural way of kind of like just jump starting the company as soon as I graduated and we went full time in Psionic. So we won like 2.4 million in grants from the National Science Foundation. It might be a little bit more now too. And in order to really get this thing to market, though, we raised a pre-seed round from angel investors and a couple of VCs, and then last year, I think we closed down our seed round, which was done through Start Engine and crowdfunding in particular. And a lot of that was just dependent on like, what was the market looking like 2 years ago, it was the worst time to raise capital from like period from VCs. And we were like, okay, so what are our alternatives here? And so crowdfunding was one of the options that we had, and it was very, very successful. We raised over 4 million on that for our pre-seed round, and now we're just scaling up our manufacturing so that we can get this hand out to as many people as possible, and then use our sales to propel us forward even further.
Yeah, on that note, I'm very curious what it's because not only is your company funded, but you're also generating a lot of sales today. And as I understand it, the demand is outpacing production right now.
Yes.
How do what is it like knowing that if you could make more of these, people would buy more? But then how do you prioritize just the day-to-day nitty-gritty of running a business without getting too drawn into the vision, if you will, that you lose track of the things that you need to do to make sure the business survives on a regular basis? Because I think a lot of very creative entrepreneurial individuals that listen to this struggle with that as well, where they've got big visions and sometimes that can take away of just taking care of the non-sexy stuff that needs to get addressed to make a business run and grow.
Oh, absolutely. And fortunately, we have a very tight knit team. So we're like when we moved here 2 years ago to San Diego, 2.5 years ago, there were only 7 of us, and now there's about 35. So we've like more than like quintupled, or we quintupled in the last like 2.5 years, and like every day we all see each other, right? And we're always like making sure that everyone knows what we're all doing. We're all heading toward the same place, and our biggest focus right now is increasing our manufacturing production, right? So making design changes of the hand that just make the DFM process like way easier. So this year we're already on track to quintuple actually our production from last year. And then we're always working on new versions of everything, right? We're designing a new version of the hand that we can eventually start to make like tens of thousands of them per year in a processing plant. So that's all in the horizon and on the pipeline, and is really putting together the team that can execute on that in particular. So we've got people who are like extremely experienced from like places like Nuvasive that we were able to recruit from here in San Diego, who have built out like entire manufacturing lines and those processes of transferring from the engineering to the manufacturing in particular, so that we can scale. And so it's exciting. It's an exciting time for us too, because it's like, okay, now as the robotics companies are starting to ask for more and more hands, we're outpacing still like the demand for humanoid robots. So as long as we stay ahead of that, we're going to be doing fine.
Dr. Akhtar, I'm going to go back to something you mentioned like a very early in our conversation. You mentioned, hey, we're using this for prosthetics, but we're also using this hand. It's AI powered as well. It can go on another robot, if you will. That's something I do want to revisit with you because I feel like those could be very two different use cases for your product. How are you balancing that as a younger company, making sure you're prioritizing both someone that is going to have this as their replacement arm, replacement hand, if you will, or as well as this being used in, let's say, a general factory setting by a robot? How are you balancing that? How are you prioritizing both?
Yeah, absolutely. And the thing is, historically, right, robots have been very specialized for particular tasks, and so you wouldn't really see a human-looking hand on a robot. It'd usually be like a gripper or a pincer or something like that, right? And with this like huge boom in AI, we've seen this crazy expansion into like the humanoid robot form factor in particular, because the jobs that you're talking about, these manufacturing lines, they are jobs that are done by humans, right? So if you're going to be having your robot do human tasks, it makes sense that you would use the device that's optimized for humans to do human tasks, right? And so the thing is, I can pop this hand off and everything is self-contained within this hand. So all the motors, all the
Yeah.
electronics and everything, right? So this is the specific connector that goes on a human user. We swap that out for a bolt circle, and then that can plug into a KUKA arm that can plug into UR5, like any of the robot arms that are on there. Aptronics humanoid robot, NASA's Valkyrie humanoid robot as well too. And the internals, it's all the same, right? And it's very unique in that sense because the thing is, like I said, if our human users can do it, then the robot users are going to do the same thing. And a story that I usually like to tell here too is that we went to NASA about a year and a half ago, and their Valkyrie humanoid robot is using our hand on it. And they were trying to do a task that you might find on the International Space Station, which is like a zipper that was on a wall, and they were kind of struggling to do it with our hand. But we had one of our user experience specialist, Annika Berlin, was with us, and she goes up to the wall, and with her ability hand, she's easily able to do it. And the NASA engineers were like, "Oh, we didn't even think about using the hand in this particular way." And so the thing is that our human operators are basically like training, work as training sets for the robot operators, so that they know what the optimal way to do a lot of these tasks are. And a lot of the tutorial videos that we put out for our human users, like cooking with an ability hand, or like doing laundry with an ability hand, can then easily translate to a humanoid robot trying to do those same tasks.
I have one more big question, and I feel like this question could be a podcast episode in and of itself. So I'm going to ask it in a way that yields just basically one answer. But, looking at a company like yours, I feel like even as, 10 years ago, it would have been very hard to do something like this based on where AI was at the time, based on where robotic manipulation was at the time. Just a lot of different technical barriers that in a very short time, I feel we've made a ton of progress on just in general. What would you say is one of the technological advancements that has made this so feasible at this particular point in time? And I'm sure there are more than a few, but if you can pick the one that sticks out the most, I'd love to get your thoughts on that.
Ooh, that's a good one. I think the biggest thing would be, or wait, which timeline are we talking about? Like 10, like within the last 10 years, or like right now?
If you want to give me both, I'd be curious. Within the last, I mean, if you have a different answer for each of them, I'd be very curious to hear what is the one that's come up over the last 10 years and one that's just very immediately front of mind as well.
Yeah, so I would say over the last 10 years, the biggest thing would be microcontrollers, like the reduction in size and the price and the processing power of microcontrollers has been
Mm-hmm.
like huge, huge, huge. Like we've got like 7 ARM Cortex M4 processors in here. Actually, I think they're M0s now, so they're even smaller than we had than before. And that was a lot harder to do 10 years ago.
Yeah.
That'd be really expensive. It'd be like the hand would not be able to be made this small. So I think on the hardware side, there's just been a lot of miniaturization on that front, as well as cost reduction. And now I think what's caught up to that as well is just the software, the AI side, right? And I think that's what we're going to be seeing over the next couple of years, is that now that we have this small power, like low power consumption, like hardware that can do a lot of processing power on here, we can use that to now run AI algorithms that are much more efficient on the device itself, rather on the edge, rather than having to do like these big supercomputers that we needed to like have before to do a lot of these like processing of like neural data and muscle data and things like that. So I think that's the next revolution we're going to see, and that's going to be able to take advantage of a lot of those things that I was talking about, like direct nerve implants. And I mean, you see like the big neurotech companies that are doing this, like was it Neuralink and Synchron and Phantom Neuro. They're all doing these brain machine interfaces, and that's going to be combined with this huge like AI push on the robotic side. And we sit at that intersection, which is just really, really unique and exciting to see, where we're bridging both like the neurotech side with the robotic side, with AI being the connecting piece between the two.
Yeah, I like that answer, and that it does bring together both the hardware side, the software side. I think
And the
uh,
human side.
and the human side, and very very great point. And I think a lot of times we default to one or the other, software and AI. I feel like get a lot of the credit right now, but I appreciate you bringing in that mix and how we are at a very unique juncture with all of these technologies and the human element all coming together. So Well, with the last part of our interview, we got to go behind the scenes at Shark Tank a little bit because I think you are the first Shark Tank alumni to be on this show. So,
Nice.
paint the picture of what it's like walking into Shark Tank, right? We see it on TV. It's this whiz bang, like what feels just like 10-minute rapid fire conversation. What does it feel like walking in to that arena, if you will?
Yeah, and you're backing up a little bit on that too. Like just even the audition process was just crazy, right? And we were actually called by the producers of ABC, and they were like, "Hey, would you like to be on the show?" And I it was never necessarily on my radar because at some this is a medical device. It's not like a direct to consumer product, right? But we had a lot of strong marketing behind it, right? We had like our like Sergeant Anderson, who was on Shark Tank with me. Like we had a video of him like punching through 3 wooden boards we set on fire, right, and to show off the durability of the ability hand. And so when we were on the phone, we were like brainstorming ideas what we can do. And we were like, we can do a live board breaking demonstration, and they were like, "Oh, this is awesome." And so some of the stats that I found out like later on was that 140,000 people or like teams applied for Shark Tank in just season 15. And of that, like 100 get filmed and 60 actually aired. So it's like less than half of a percent of like actually getting on the show. So had I known that, I might not have gone through like the entire process for doing it. But you're on there for like 45 minutes, and then they condense it down. They edit a lot of things down to about 10 minutes. And one of the things I was so sad that they had ended up editing out too is that Mark Cuban actually did the same demo that you did, where you actually got to control the hand. But it didn't actually make it into the final cut because they needed to just reduce a lot of the time on that too. So, but it was exhilarating and nerve wracking at the same time. The room feels way bigger than you ever think. Like the sharks are like 20 feet away from you, but the cameras are so far, it makes it look like it seems a lot closer. And yeah, there was just it was just a lot of it was like if you pitched to VCs before, a lot of it was just the standard VC pitch. So if you know your numbers really well, then nothing is really different on that front. But the only thing that was scripted was like the first 2 minutes where I gave my spiel, right? Where we had Sergeant Anderson do the board breaking demonstration, but then it's just 40 minutes of just rapid fire grilling from the sharks.
Yeah, so what I like about that is there are some, like, you're practicing for that every day, basically. There are a lot of similarities between, yeah, a lot of similarities between that and an everyday VC pitch. Let me ask this, and I don't want to give everything away because I'll have a link to this in the show notes. I think people should go watch it for themselves. What is it like being in that moment, though? Because there is some showmanship to this. What is it like, having, Mark Cuban and then Robert pass up on you before you get into the negotiation with the other folks? How do you navigate that in that moment to just stay on your game?
It's funny because those were the two top sharks we were targeting in the first place too. And honestly, I think we went through a bunch of scenarios too, like in just like practicing for it as well. Like, what happens if like all the sharks say no? Like, what happens if like various sharks say yes? Like, and so I don't know, a lot of it you can't prepare for it. I wasn't sure what to. I was definitely not expecting to for like three sharks to come together, right? And let alone which three sharks they were, and so yeah, a lot of it was just kind of like spur of the moment. Let's see what happens, and let's see where this can go.
And one thing I imagine is the case with a lot of these. The deal you end up negotiating, how do you prepare for that to know what your walk away amount is, what's going to be a fit, where you're willing to make compromises? How do you prepare for that part? Because you can prepare, you obviously had your pitch ready to go. It was very well orchestrated. I was really impressed, and also just how you fielded all the questions leading up to that. But of course, the negotiation, I think, is that I would imagine that's the trickiest part, just being able to make some very big decisions in that moment. What was your strategy going into that, out of curiosity?
Yeah, absolutely. And so we had Start Engine going on at the same time, and so we had a strict valuation that we wanted to stick to in particular. And so one of the ways that we had strategized on how we could approach that is that we can keep our valuation at, like, I think it was at the time it was 50 million, and now it's higher than that. But any additional equity that we give up would be advisor shares to the sharks that would come on board. And that strategy actually worked out pretty well, that we could that way preserve our valuation while still having the sharks on as advisors. But also, Shark Tank, like what ends up happening on the show, is the starting point of negotiations in the real world too. So it's not like the deal that is made on the show is like that is like final, like the papers are signed right there. Then it goes on for a while in due diligence and all of that. So and knowing that takes a little bit of the pressure off too. Because you know that like whatever is negotiated at that point is just going to be kind of like the starting point of real world negotiations as well.
Out of curiosity, what is your biggest takeaway so far from having such, high caliber, well known investors in this space? What is the biggest thing you've learned, or how has that been a benefit to the evolution of your company?
Yeah, I think the biggest thing is seeing all the excitement around this field that, again, like if we're looking back 10 years, it wasn't there, right? I mean, there was like the DARPA robotics challenge that happened, and like Google was buying a bunch of like robotics companies about like 10 years ago, but then like, that hype train went back down, and now it's like way back up. And so seeing the amount of interest, especially at the intersection of like neurotech and robotics, I think that's something that's very nascent and like starting to grow a lot more than it was ever before. And having big investors behind that just is a testament to like this is an exciting field that's up and coming and emerging, and it's what I've wanted to work on my entire life. So it's a little validating on that front.
Yeah. No, well, like I said, I encourage everyone that's listening to this, if you haven't, go check out Dr. Akhtar's performance on Shark Tank. Very impressive. The last thing I'll ask, hey, is there anything you wish I would have asked that I haven't yet? We covered a lot of ground in today's conversation. Is there anything you wish I would have brought up, or a final piece of advice you want to leave the audience with?
I guess as a final piece of advice, uh, I think for me, approaching things from just a um, a lens of just gratitude has been immensely helpful, right? I'm incredibly grateful that I get to work in a field that I've loved my entire life, that I've wanted to work in my entire life. And, that's what makes like the 80-hour work weeks so like doable, because it's my life's work. And I'm incredibly grateful that I have such a supportive family and supportive team to make this vision and this mission come true. And coming from a lens of gratitude has been immensely helpful to our success. And I think for a lot of companies, viewing things through that lens would be just extremely helpful as well.
Yeah. I appreciate all the advice you've given us today, sharing your story, ending on a note of gratitude as a call to action for our audience as well. Dr. Akhtar, I'm looking forward to hanging out with you in Boston soon. Thank you so much for jumping on Manufacturing Happy Hour.
Thank you for having me.
Cheers.